Hey guys, so in the last video, I talked to you guys about how to change the equilibrium and the amplitude of a sinusoid. So equilibrium is like sort of like where the middle of the output is, and so we talked about how you could like move that middle line up or move that middle line down. And then amplitude is how far the graph like stretches away from the middle. So we talked about how to like stretch it further from the middle if you wanted to. The other period of sinusoids that we're going to talk about today is called the period. The period is the length of the cycle. These are periodic functions, meaning they repeat themselves over and over again. And so the period is how far you have to go to see a full cycle of the graph, or how long it takes the graph to repeat itself. And the standard for that is 2 pi radians, or 360 degrees. That's true for both sine and for cosine, that if you want to know the length of a full cycle, how long it takes for the graph to repeat itself, you have to go to 2 pi. And that's because if you think about all of our angles, right? Like if I have all my angles and I go around 360 degrees, if I keep going, I just repeat myself. Every 2 pi radians, you just repeat yourself. The cycle just starts over. So because period has to do with a horizontal property of the graph, it has to do with x, to change the period of a graph, you actually have to make a change inside the function. So what I'm going to say is if I wanted to change the period of a sine wave, I can make a change inside the function. Like, for instance, I could ask us to graph y is equal to the sine of 2 times x. Something you might remember from earlier this year is that anything that happens inside the function is counterintuitive, meaning you do the opposite of what you would think. So if it says 2 times x inside the function, you actually take every x value and you divide by 2. Because inside the function means do the opposite. So what's going to happen is that a normal sine wave completes its cycle in 2 pi. I'm going to take that x value and I'm going to divide it by 2. So instead of completing one full sine cycle in 2 pi, I'm actually going to have that point divided by 2. I'm going to complete a full sine cycle in pi radians. The graph is going to squish horizontally. You actually get a full and complete sine cycle in half the space it took you previously. So the period went from 2 pi to just being pi. And if you kept going, that graph would repeat itself so that by 2 pi, I would have like a second full cycle. By 3 pi, I would have a full third cycle, etc. That I took the standard period of 2 pi, I divided by 2 to get my new period, which in this case was pi. It turns out there's a really easy way to remember this, that just like the vertical stretch is the amplitude, the vertical shift is the equilibrium, if we call the number inside the function b, b is what you multiply by inside the function. If you say that number inside the function is b, the new period of your graph will always be equal to, not 2 pi times b, but because it's inside, it's the opposite. It will always be 2 pi divided by b. So that's the equation we'll be working with today. The period of a sinusoidal function will be 2 pi divided by b. So in this case, the period was 2 pi, I divided by 2, the period became pi. So I had a full cycle in just pi radians. Okay, so I'll give you another example. Let's say I asked us to graph y is equal to the cosine of 1/4 times x. In this case, the b value, what's being multiplied inside the function is 1/4. So the period is going to be 2 pi divided by 1/4. What you might remember is when you divide by a fraction, you multiply by the reciprocal. So this is going to turn into 2 pi times 4 over 1, or just 2 pi times 4. The period for this function is going to be 8 pi. That means the period is not 1/4 what it usually is. The period is 4 times longer than it usually is. So when I go to draw my cosine graph here, it's still going to look like a normal cosine graph. It's going to start at its maximum, but the period is 4 times as long. This graph like really stretches out so that the length of a full cycle is now 8 pi. Something I talked about in the last video is how you usually have sort of like 4 sections of one of these graphs in accordance with the 4 quadrants. So like 1 quadrant, 2 quadrants, 3 quadrants, 4 quadrants. For that reason, I often don't just think about the period. I also think about what I would call the quarter period, a fourth of the period. The quadrants will always take 1/4 of the period. So if the full period is 8 pi, a fourth of that is 2 pi. That means this happens at 2 pi, this happens at 4 pi, this happens at 6 pi. The full cycle happens in 8 pi. So when I multiply by something inside the function, my graph shrunk horizontally, so I had a really skinny period. When I multiplied by this tiny little fraction, my graph actually expanded horizontally. My period got 4 times as long. Okay, so we're going to keep working with this equation today, just so we can see a lot of different sinusoids with a lot of different periods. So I'm going to erase all of this. And I am going to ask that we consider this equation right here. Y equals the sine of pi over 10 times x. We're going to graph that. Okay, so in this problem, the b value, the thing being multiplied inside the function, is pi over 10. Don't worry if your b value has pi in it. That actually is going to make the problem easier. It's really nice. So the b value is pi over 10. I know from this equation right here that the period is going to be 2 pi divided by the b value. Okay, so the period is going to be 2 pi times the reciprocal, 10 over pi. The pi's cancel. It turns out that for this function, because there was a pi built in, the period of this function is just the normal number, 20. So here's what you can do to graph this function. Really easy. Just draw a normal sine graph. Sine starts at the equilibrium and it heads up. 1, 2, 3, 4. So if your period is 20, that means the amount of time it took to complete a full cycle is 20 units. And then I will usually write down for myself what is a quarter of the period. What's a fourth of the period? Since I have 4 quadrants, I want to divide the period into 4 pieces. 20 divided by 4 is 5. Meaning this point happens at 5, this point happens at 10, this point happens at 15, and I have a full cycle in 20 radians. Okay, so we're going to try to put the pieces from today together with the pieces from last time so that you guys can try to do a problem that has a change of amplitude, equilibrium, and period. But I actually think you're going to be so fine with this because you've got the pieces from last time down. So, big scary looking equation. Get some more colors out. Let's say that we were looking at the equation y equals 3 times the cosine of pi over 6 times x plus 5. All right, so what I usually do when I see a sinusoid that has a whole bunch of changes is I write out the properties I expect. So I'm going to start by saying I expect that the equilibrium for this graph will be the vertical shift. The equilibrium will be the line y equals 5. So if I want to start drawing my picture here, I know that the equilibrium for this graph is at a y value of 5. And I'm going to draw a little dotted line there, so that's really clear. Okay, the amplitude for this graph, how far above and below I stretch, is 3. So if I go 3 up, my maximum is at 8. If I go 3 down, my maximum, or my minimum, is at 2. So there's my max line, there's my min line. Okay, so then lastly, this is where we use the new piece. The period of the function is going to be 2 pi divided by the b value. And in this case, our b value, the thing being multiplied inside the function, was pi over 6. So my period is 2 pi divided by pi over 6, also known as 2 pi times the reciprocal 6 over pi. The pi's cancel. The period for this function is 12. So what we can do is we can draw a cosine graph. Cosine always starts at its maximum. So I do 1, 2, 3, 4 sections. And I say the amount of time to do that cosine graph was 12 units. It took 12 units to complete the full cycle. If the full period is 12, a quarter of the period, 1/4 of the way, is 12 divided by 4, it's 3. So the first quadrant ends at 3, then 6, then 9. Full cycle in 12 radians. If you guys understood that, that is literally everything we've done so far. You are in awesome shape. I'm going to do a couple more examples that just go the opposite way, but these are all the pieces of the puzzle. You set up an equilibrium line, you stretch to a maximum, you stretch down to a minimum, and then you use 2 pi over b to figure out how long it takes to do a full cycle. All right, so what I'm going to do now is show you a problem where I give you a graph and we try to figure out what's going on with it. I'm going to give you a tip for problems where you go this other way. It's actually really easy. If period is equal to 2 pi over b, that means that b is also equal to 2 pi over the period. There's actually no way to mess this equation up. Period is 2 pi over b is 2 pi over the period. So check this out. For instance, let's say I saw a graph that looked like this. Let's say I saw a graph that started equilibrium, goes up to a max. And I'll say that this just sort of has a standard equilibrium of 1, a standard amplitude of -1. So it's a basic sine or cosine wave. I actually know that it's sine because it starts at equilibrium and goes up. So I'm like, okay, this is some sort of sine graph. And then I'm going to tell you that the period of this function is 40. That the points go 10, 20, 30, 40. The length of the full cycle is 40. So this is really easy. You can say the period of this function equals 40. So the b value, the thing that goes inside the equation, is 2 pi divided by 40, also known as 1 pi divided by 20, because 2 over 40 makes 1 over 20. So the equation of this graph is the sine of pi over 20 times x. It's that easy. I can give you a totally different looking one. Let's say I gave you a graph. Again, we're just going to have a standard sort of amplitude and equilibrium. Let's say you had a graph that looked like this. And I told you that the period of this graph was pi over 5. Period of this graph is pi over 5. That's how long it takes to complete a full cycle. Because I just have my standard equilibrium and amplitude, I think this is just a standard cosine graph. Y equals the cosine of something. And to figure out the b value, I can say, okay, the length of a full cycle was pi over 5. So the b value has got to be 2 pi divided by pi over 5. Okay, so dividing by a fraction, that's just multiplying by the reciprocal. So the pi's cancel. I have 2 times 5, which is 10. The b value is 10. This is the graph of the cosine of 10 times x. Boom. It's that easy. So I think that that's enough for now. I put up some homework problems online. If you're having a tricky time with them, I'm going to add some office hours on Monday to give you guys some help. Mainly, you're just going to want to have these two pieces of the puzzle. The period is 2 pi divided by the b value. The b value is 2 pi divided by the period. It's often useful to divide the period up into quarters to find 1/4, or period divided by 4, because that's how often you will have special points happening. Good luck, everybody. Shabbat shalom.